Dear students, welcome to a new video for the Pure Mathematics course. Here we will begin to the subsection 1.4, which is linear inequalities. Supposing A and P are 2 points of a real number line. The relative positions of 2 points may be A less than P or P, which is mean P greater than A, or it may be A greater than P, which is mean P less than A. So we have two numbers and one is greater than the other or less than the other. So the inequality is a statement that the number is less than or greater than an expression. So we can have a standard form for the linear equalities that can be written as shown here. Ax plus p less than 0, where A and P are two constants and A never equal to 0. To solve any inequality involving a variable, it should be find all values of the variable which make the inequality true. I mean that we will solve by using all tools to get the value for x, for example, if the x is an unknown variable. So, see the results for the inequalities may be in the intervals given in this table. The interval notations for x may be a type of closed or semi-closed or open or closed interval. So we have these forms. Let's take an example and show how to use this table to get the answer in the form of the intervals. Now we will solve the example number 37. Solve the following linear inequality. 2 times x minus 3 less than 4. Now we will distribute 2 inside the brackets and get 2x minus 6 less than 4. Adding plus 6 to the both sides, we get 2x less than 10. Dividing both sides by 2, we get x less than 5. So we see that the solution for this inequality is all the values that less than 5. Let's imagine it for in the line of x. If we have here 5 and this is 0, and the number from positive infinity to negative infinity. So the solution is all the values that less than 5. All the values that less than 5. Here, this means that we have here from 5 up to negative infinity. And 5 not included because the time don't have the equal sign. It's only x less than 5, not less than or equal. So we can use the interval form to get the solution for this inequality by writing as follows: a curved bracket and negative infinity and 5 and a curved bracket because it is not a equal sign. So this is open interval. This means this open interval, and we have here negative infinity and here 5 that have an equal sign. If we have solved this linear inequality, 3 minus 2x less than or equal 6. This means that we will add to the both sides negative 3. Negative 2x less than 3. Then we divided both sides by negative 2 to get rid of the coefficient of x, which is negative 2. So in the case of multiplying or adding the both sides by negative number, we should change the direction of the inequality. Take care from this point, it's the most important thing in the inequality solutions. Don't forget, please take care that if you multiply or divide the both sides by a negative number, you should change the direction of the inequality. So we divided by negative 2, the value will be x greater than or equal negative 3 over 2. Let's imagine it in the line number. If we have here negative 3 over 2, or it's meant by negative 1.5, and the values for the solution, that's all numbers that is greater than or equal this value. Here it's the positive infinity direction, and here it's a negative infinity direction. So the value or the solution is from negative 3 over 2, and the 3 over 2 is a number included because we have equal sign for the inequality up to positive infinity. So the interval form will be semi-closed interval, which have from negative 3 over 2 up to positive infinity, like this. Let's move to another example. If you have 3 over 2 times s minus 2 plus 1 greater than negative 2 times s minus 4. So we have multiplying both sides by 2 to get rid of 2 in the denominator. So we get 3 times s minus 2 plus 1 greater than 2 times negative 2, negative 4, s minus 4. Then we will distribute 2 inside the brackets. So we will get 3s minus 4 here plus 2, 3s, 3 times 2 equals 6x minus 4, then minus 4 plus 2 equal to minus 4, and greater than negative 4x plus 16 by distributing 2 inside the brackets. So we will get s in the left hand side and the numbers in the right hand side as follow: 3s plus 4s equal to 7s, and adding plus 4 to the both sides we get 15 plus 4 equal to 20. Dividing both sides by 7, it's a positive value, so we shouldn't change the inequality direction, so s will be greater than 20 over 7. Note that if we get it on the line number, we put 20 over 7, and we haven't an equal sign in the inequality, so the 20 over 7 not included, which is open interval, curved interval, and it's greater than the solution is all values that greater than 20. Here up to positive infinity, here negative infinity, so this is the solution, all these values. So the solution will be 27 and okay, this is what for the inequalities. Let's now move to the absolute value. The absolute value is on a real number is the distance of x from 0, which is x denoted from here, maybe to 5 units in the right hand side or 5 units to the left hand side. So we don't know the actual value for the x. Now the absolute value of a real number is written in this form. This is called the absolute value sign and defined by x, positive x if x greater than or equal 0, or negative x if x less than 0. So we have two values of x. We will learn how to solve the absolute values for equations and then for the absolute value for inequalities. First, solving the absolute value for equations. We have absolute value for x minus 3 equal to 2. This means this absolute value or these equations have two signs, maybe 2 equal to or negative 2. So we put the value in this form where x minus 3 equal to 2 or x minus 3 equal to negative 2. We just here eliminate the absolute value sign and get two equations like this and solve all the steps by using the equation steps as normal. So we can get x minus 3 equal to, here x will equal to 5, or x minus 3 equal to negative 2, so the x will be 1. And this will be two solutions for the absolute value equations. Let's take another example. X minus 3 absolute value for x minus 3, absolute value for 7 minus 3x is equal to 5. Again, we will do the same steps. Please take care. We will get rid of the 2 or eliminate the 2 brackets or the absolute value here and get the right hand side, the first in both positive sign and then with a negative sign. So the equations will be 2 equations like this. 7 minus 3x may be equal 5 or 7 minus 3x equal to negative 5. And solve as usual to get x equal to 2 over 3 or maybe x equal to 4. Let's move to the third example for absolute value equations, which is x minus 4 equal to negative 3. Here, don't make any more steps. Just what we find that the absolute value equal to negative number, so the solution set will be 5. There is no solution because the absolute value never be a negative number. Now, let's move to the absolute value inequalities. And this table is a summary for the solutions for the values in the equations. If we have absolute value of x is less than d, where d is greater than 0, the solution will be in between negative d and d. And if we have the absolute value for d greater than for x greater than d, so we have two values, which is x less than negative d or x is greater than d. So we will use the absolute value inequalities to get two inequalities like this. If we have in the first example x plus 5, the absolute value for x plus 5 greater than or equal 7, this means we have two inequalities. One will be x plus 5 is greater than or equal 7. The same inequality, just we eliminate the absolute value brackets or absolute value sign. And we have another inequality, which is x plus 5, the left hand side is the same, but the right hand side we will change the direction of the inequality and change the sign of the number. So x plus 5 is less than negative 7. And we will solve the solution and get the solution by solving the two inequalities as usual by the test of the inequalities and get finally x plus 5 greater than 7, so x will be less than equal be x greater than 2, and when x plus 5 less than or equal negative 7, so the value of x will be less than or equal negative 12. Now we will write the two inequalities in only one interval, because in the basics we have only one inequality, which is the absolute value inequality. So return back to the absolute value inequality and combine the two inequalities in one line to get the here x when x less than or equal negative 12, so the interval will be negative infinity up from negative 12 up to negative infinity. And when x greater than 2, the interval will be from 2 up to positive infinity. The two values, if you imagine here in the line, here 2 up to positive infinity and here negative 12 up to negative infinity, the two intervals are not intersected. So we will combine the two intervals by using the union sign. The union sign as here in the example. Let's move to another example for the absolute value inequalities. Here, if we have the absolute value of 3x minus 4 less than 1, now we will use this inequality and get two inequalities. If 3x minus 4 less than 1 with the same sign and the same direction for inequality, and the other one or the other inequality will be 3x minus 4, change the direction of the inequality sign and change the sign for the right hand side to be negative 1. So we have another equality, which is 3x minus 4 is greater than -1. Solve the two inequalities as inequalities steps as usual and get the two in one line. So there is an interaction in between the two lines, and the value will be from 1 up to 5/3 only. So there is the interval for the solution is x in between 1 and 5/3. Here, another more example for the inequalities. 3 times 3 minus 2x plus 7 less than or equal 4. In this step, we should get rid of all the numbers that are added or multiplied to the absolute value. So we will first add -4 to the both sides to get here 3 times 3 minus 2x absolute value is less than or equal 7 minus 4, which is equal to 3. And then dividing both sides by 3, we get the absolute value for 3 minus 2x less than or equal 1. Now solve with the absolute value inequality by the same steps by getting two inequalities. The first is 3 minus 2x, which is less than or equal 1, and the other is 3 minus 2x, changing the inequality direction and changing the right-hand side sign to be -1. So the solution will be the interval in between 1 and 2. Take care that the right-hand side of the inequality never be a negative number. Again, the same as for the equations. If we have, for example, 3 minus 2. Now let's move to another topic, which is the functions, graphs, and lines. Chapter 2, we will begin with the functions. A function is a rule that assigns each input number to one output. So, to each element in X is a unique value in Y. And now we have two main sentences, which is domain and range. The domain is the set of all inputs number which in the function, and the range is the set of all output number in. To assign domain for a function, we have a variable forms of functions. The first form, which is the polynomial functions, like the function here, that f of x, 3x minus 12, or quadratic functions, any function that not fraction or radical function that in a polynomial form, the domain for it will be all the real numbers. Also, the constant functions that have no variable in the right-hand side, which is the constant functions, also the domain for it will be the all real. Now, another type of the function that have a vertical sign. Take care from this type, because the domain will be changed, not all the real number. You know very well that we can have a radical sign with a negative number. So we should keep the value for under the radical sign all the time in a positive value. So if we have f of x is equal to a radical value, which is here as example, root x minus 3, we will take the value in that is under the root sign or under the radical sign, and you should get it greater than or equal 0 to ensure that the value inside the root is positive, not negative. Maybe 0 is not okay, but not less than 0. So you solve the inequality under the radical sign as an inequality by getting the right-hand side of it greater than or equal 0 and get the interval. So this interval will be the domain for your function. Another example here, if we have 6 minus x root 6 minus x is our function. What is the domain? The domain gets the value which is under the root sign or the radical sign and get it greater than or equal 0 and solve as the inequality stops at 0. So the interval will be or negative infinity and 6 at a semi-closed interval, and this will be the third type of the function, which is the fractional function. Fraction functions that the denominator here is have a variable. So x minus, as example, if we have f of x equal to x minus 6 over x plus 3. What we can do in the case of the fraction, that we get the denominator and we should get it as inequality, equations, but not equal to 0. The domain for the fraction function that the values that make the denominator never equal to 0. So solve the denominator here always for 0 and eliminate the 0 values that get the that in the denominator. So the domain here all the values except x equal to -3. If we have the two cases in one example like this, here the fraction and in the here in the denominator is a radical sign. So we get 2 minus x not equal to 0 and all not equal are also not equal to 0, greater than 0. In the case of radical, when it's in the denominator, we take it as greater than or equal 0, but the radical sign in this example in the denominator, so we can't write it equal. So we should eliminate the equal sign and get 2 minus x is greater than 0, and this will be our domain or for the interval. Here, another example that we have two in the denominator, two polynomials multiplied by each other, which is x over x minus 2 multiplied by root x minus 1. Here, this value for x minus 1 should be greater than 0 and at the same time x never equal to 2. So our domain will be x greater than 1 where and except x equal to 2. This is the domain for this function. Now, finding the domain and the function values. Any real number can be used instead of x. So the domain for g for the real numbers. If we have the function g of x equal to 3x squared minus x plus 5. Now g of z, if we have z institute of x, so the function will be g of z equal to 3z squared minus z plus 5. All what we do is that we substitute every x with z. The same for r squared. We will substitute every x for r squared. Take care that you have already squared for here in the x, so don't eliminate it. Take care when we rewrite your function. So g of r squared will be 3r to the power 4 minus r squared plus 5. Now we can substitute any values by any symbols and any numbers in your function. Let another example when we have g of x plus h, substitute g x for each x and get x plus h inside. So we have this value. Now move to another type of the function, which are fractions or r factorial. Factorial is r of r is a positive integers that represent the product of the first r positive integers. I mean the rule that if we have r factorial, we find r times 1 times 2 times 3 up to r, and 0 factorial is equal to 1. A factorial function, maybe it's a constant function, it's not, but you should know what is meant by factorial if you find it in any topics. So 5 factorial, for example, equal to 5 times 4 times 3 times 1 up to 1 only, not 0, of course. So it will be 120. 3 factorial times 5 minus 6 minus 5 all factorial equal to 3 times 2 times 1, and 6 minus 5 factorial equal to 1. Take care, it differs from 6 minus 1, 6 minus 5 factorial equal to 1 factorial, but 6 factorial minus 5 factorial is not equal to 5 minus x factorial. This differ in the form of this. Okay, here another example, 4 factorial over 0 factorial. Of course, 0 in the denominator you may be, it's not defined. No, 0 factorial is equal to 1. So it's defined by multiplying 4 times 3 times 2 times 1 over 1 2p 24. Now we will move to another important topic of functions, which is combination of two functions. If we have a combination of two functions like this, f of x equal to 3x minus 1 and g of x equal to x squared plus 3x. Now you can find the addition of two functions by adding the two functions together. It's was not concerning to what's first or the sign, because adding is a commutative property, so you can add f of x plus g of x simply like this to get x squared plus 6x minus 1 by simplifying it. Now find the combination for f minus g of x. To get f minus g, take care that what is first, f minus g or g minus f, and take care of your signs, please. So simply 3x minus 1 for f of x minus for the rule and x squared plus 3x. By simplifying it, we can do it in this form, minus x squared minus 1. To find f times g of x, we can multiply two functions by each other to get 3x to the power 3 plus 8x squared minus 3x. And also we can combine the two functions by division by dividing f of x over g of x, which is equal to 3x minus 1 over x squared plus 3x. And also we can multiply a constant by f of x by x in half. Okay, for example, half times f of x. So equal to half times, substituting the value of f of x here, 3x minus 1, 3x minus 1 over 2. Another very important topic for the combination of functions, which is a composition. Composition, this means that we get a value of two functions composed to each other. Okay, so the composition read as follows: f circle g of f equal to f of g of x. So we get the value of x by getting first the value of g of x. Let's take an example. If you have f of p equal to p squared plus 4p minus 3 and g of b equal to 2p plus 1. Now find f of g of p, or what is meant by f circle g of p. Now we first get g of p. Begin here from inside. Substitute the inside value, okay, by its function. So we can get f of 2p plus 1. And then don't look at this value because you already use it in the substituting in the first step, and get in this step the value of f2p plus 1 by substituting hp by 2p plus 1, as we mentioned before for r squared, for x plus h in the examples in the previous slides. Okay, now we got it 2p squared, because here is p squared, 2p plus 1 all squared, 4 times p, substitute p by 2p plus 1, so will be 4 times p 2p plus 1, and negatives we get the same. Simplifying it, we get it to 4p squared plus 12p plus 2. Now you can solve the same example by getting G circle f of 1. This means that we first get G circle f of p, and then getting the values for p by substituting it each p by 1. Okay, let's move to a hint for how to mention for the graphing or how to draw a line. In this lecture, we will begin or we mention to how to get a line. We have what's meant by a rectangular coordinates. This is meant by a rectangular coordinates or XY plane. So we have a horizontal axis and vertical axis, and a rectangular coordinate system. This provides a geometric way to graph equations in two variables. So in this coordinate, we have a geometric way to graph equations in the two variables. Now, we will mention some terminology that we have, that is here, the intersection of the two lines, vertical axis and horizontal axis, or what is meant by x-axis and y-axis, is the origin point 0 and 0. Here, 0 and 0. And any points in the coordinates is called the order pair x and y. Order pair x and y. And we have four quadrants. This is the first quadrant, and this is the second quadrant, third quadrant, and finally it's the fourth quadrant. So we have four quadrants. Now we have X-Intercept. X-Intercept is this point where the curve or a line intersect with x-axis, and we can get the value of X-intercept by setting y equal to 0 and solving for x. By the same way, y-intercept is a point here that our line or curve intersects with the y-axis, and we can get the y-intercept value by setting x equal to 0 and solving for y. Now let's take an example. Here, if you have y equal to 2x plus 3, find x-intercept substituting here y equal to 0, so the x-intercept will equal to, will equal to negative 2 over 3, negative 3 over 2. And the y-intercept substituting x equals 0, so the y-intercept will be 3. And the domain, because it is a polynomial function, will be all the real numbers, and also the range is all real numbers. Thank you for this. Now we already covered the rest of chapter 1 and the beginning of chapter 2. We will continue in the other lectures for the rest of chapter 2.